welcome to the final lesson of Chapter 6. We've covered testing fundamentals, the Mocha framework, Docker environments, and continuous integration. Now we tackle two remaining critical topics, code coverage and benchmark testing. Let's start with code coverage. Having a test suite is great, but how do you know whether your tests actually exercise all the code you've written? Code coverage is the metric that answers this question. It tells you what percentage of your code is executed when your test suite runs. A higher coverage percentage is generally an indication of lower bug probability because more of your code has been verified by tests. Coverage is measured across several dimensions. Statement coverage, what percentage of executable statements are run? Branch coverage, when your code has an if/else, are both the true and the false paths tested? Function coverage, is every function called by at least one test? Line coverage, what percentage of code lines are hit? The challenge is that you can't calculate coverage just by looking at code. You need a tool that instruments your code. It inserts counting logic into a copy of your source, then runs your tests against that instrumented copy and reports how many times each significant line was executed. In Node.js, the standard tool for this is Istanbul. Install it and its Mocha reporter plugin globally, sudo npm install g Istanbul Mocha Istanbul. Here's the workflow. First, create an instrumented copy of your module, Istanbul instrument module.js instrumented.js. Then update your test file to require the instrumented version instead of the original. Then run Mocha with the Mocha Istanbul reporter, Mocha reporter Mocha Istanbul test.js. Instead of showing test descriptions, this reporter generates a coverage summary showing statements, branches, functions, and lines each as a percentage. It also generates an HTML report folder containing index.html. Open this in your browser for a full visual coverage report. You can click into individual files to see exactly which lines were hit and how many times, and which lines were never reached by your tests. Lines with a 0 hit count are your blind spots. Add tests to cover them. For teams using continuous integration, you can set coverage thresholds. Refuse to merge a pull request if coverage drops below 90%. This keeps the team honest about maintaining test quality as the codebase grows. Benchmarking is the process of running a set of tests to measure specific performance metrics, usually time per operation or operations per period of time, in order to compare them with past results or with alternative implementations. The most important benchmark metrics for Node.js applications are response time for individual operations and throughput, how many operations per second your system can handle under load. Here's the key mindset: take benchmarking seriously, but don't lose sleep over it at the start. When you're beginning application development, you don't yet have baseline statistics to compare against, and you don't know which operations will actually become bottlenecks. Start simple. Start with the most user-visible operations. Simple list fetches, like a history list, should complete in under 100 milliseconds. More complex operations that involve rendering or heavy computation should ideally stay under 500 milliseconds. Operations that take more than 2 seconds for a simple task will cause users to perceive the application as slow and unreliable. Mocha makes benchmark testing straightforward because of its built-in timeout mechanism. Remember, the default timeout is 2000 milliseconds. Here's how you use it for benchmarks. Create a test file, let's call it timeout.js. Inside, use this .timeout, 100, to set a 100 millisecond budget. Then write your test as an asynchronous test by accepting a done callback. When your operation completes, call done. If the operation doesn't complete before the timeout expires, Mocha fails the test with a clear error message, timeout of 100 milliseconds exceeded. This is powerful because it integrates performance requirements directly into your regular test suite. Your CI pipeline will automatically catch performance regressions. When a benchmark test starts failing, it's a signal that your code has become too complex for the current data size, or that your data has grown to a point where the algorithm no longer scales. A few important benchmarking practices: always benchmark against a copy of production data, or a representative subset if production data is too large. Never benchmark on the production server itself, the overhead of running tests will impact real users. And always ensure you're benchmarking with consistent, known test data. Benchmarks against variable data give you variable and unreliable results. We've covered all the technical tools: Mocha, Docker, CI, Istanbul, and benchmark tests. Let's now talk about analyzing your test suite results and building a culture of quality around testing. Beyond pass and fail, Mocha provides rich analysis data. First, test durations. Even for tests that aren't benchmark tests, Mocha reports how long each test takes. Review this data regularly to identify tests that are becoming slow. These are early warning signs of performance degradation. Slow tests are also painful for developers because they slow down the feedback loop. Second, Mocha can generate test reports in various formats. These reports can be saved, compared over time, and used for quality assurance review meetings. For Node.js specific concerns, Mocha provides additional analysis capabilities. Memory leak detection. Mocha can look at global variables before and after your tests to detect leaked global state. Uncaught exception detection. If your code throws an unhandled exception during a test, Mocha identifies which test caused it, rather than crashing silently. Seamless asynchronous support. Mocha handles async tests natively with the done callback pattern, and supports promises as well. Node.js debugger support and browser support round out the toolkit. Now for the strategic perspective. A proper test suite is like having a quality assurance engineer who tests your entire application every single time you make any change faster and more consistently than any human. If your application has multiple developers, enforce a minimum coverage threshold. 90% is a reasonable target. Automate coverage checks in CI. Use the coverage metric as a gate for merging new features into the main branch. Make test results public within the team. When everyone can see the test history and coverage trends, it creates positive social pressure to maintain quality. Developers are motivated to keep tests green because their professional reputation is tied to the health of the test suite. The ultimate goal is a test suite you can completely rely on. When the test suite passes, you can confidently deploy. When it fails, you know exactly where to look. This transforms testing from a chore into your most powerful tool for shipping high-performance, reliable Node.js applications.